AP Chemistry, Unit 3.8 and 3.10, Separations of Solutions as well as Solubility. So for particulate diagrams, those are used to represent interactions in between components of a solution, so your solute and solvent. They're also going to be able to represent relative concentrations of those components. As a reminder for any particulate diagrams, make sure that you have the correct orientation in between your ions and your solvent particles. Typically your solvent's going to be water, so making sure that your water is oriented appropriately toward or away from your ion is going to be very important. And make sure that you use your correct number of particles relative to the concentration. So water is often represented using this kind of Mickey Mouse head looking thing, and the ears of the Mickey Mouse are for your hydrogens, and they are partially positive, whereas the Mickey Mouse head is partially negative. That is your oxygen. Remember that oxygen's more electronegative, so it pulls those electrons towards itself away from the hydrogens, and so the hydrogens have less ownership of those electrons, so they are partially positive, whereas your oxygen head is going to be partially negative since it has a greater ownership over those electrons. Remember also that opposites are attracting, so your hydrogen ears of your water should be oriented toward any anions, and your oxygen head should be oriented toward your cations. For solubility, solubility is my ability or capacity in order to dissolve into a given solvent. The default solvent is going to be water, so unless otherwise stated, the solvent is water. If it is soluble, that means it can dissolve. If it's insoluble, it means it cannot. Miscible means that we're dealing with multiple liquid things. So instead of soluble and insoluble, we like to use miscible and immiscible. Immiscible means that two liquids can mix or dissolve into each other. Immiscible means that they cannot mix or dissolve into each other. Aqueous solutions are going to be solutions in which the solute has already been dissolved into the solvent. Remember also that like dissolves like, and so substances with similar intermolecular forces to the given solvent will dissolve. And so for polar solvents, you can dissolve things that are also polar or are ionic, since we have dipole-dipole interactions and dipole-ion interactions. And then for nonpolar substances, only other nonpolar substances can dissolve into them, since they only have London dispersion forces to rely upon.